today?
Yeah.
Okay, let's share the whiteboard. Whiteboard, let's go. All right. Any question today? Complex, no? What is a complex cubic equation? Complex number. So what is your question today?
I wanted to talk about how to express things in polar form.
Can you write down? Corner form? What's that?
Mm-hmm.
Can you write some question to have a look? Complex number, right? Complex number.
Mm-hmm.
Polar form, yeah, polo, yeah, polar form, yes. So polar form, so basically we have the complex number in general that can either written as x plus iy, or you can use r multiply cosine theta plus I sine theta. So the second one, the second is a polar form, right?
Mm-hmm.
Now, in your case, obviously, we got this x and y, right?
Mm-hmm.
So basically, if you go to the complex number, so that is give you some general relation. So if you go to the complex number, to any complex number, say the z, right, can be represented by either use x or y. Can you see? So this is real, this is imaginary. So if you use Cartesian, you can use x and y, or you can use a coordinate. You can use this r and theta. So there is a simple relation between these different coordinate just by use geometry. See, this r is theta. You see. So in this triangle, what is the relation between these two? So basically, we need to work out what is r. So we need to work out what is r and what is theta. So given, so we have this x, y given, can you see? Given x equal to -2, y is equal to -2 square root 3, isn't it?
Yeah.
Yeah, it's simple. This is much simpler than the question you asked last time. So what is r, what is theta? Yeah, you can use the Pythagoras theorem as r. Here's question 1. How do we work out the r? Do you know the formula, the tan inverse? Is it this formula?
Yes.
And also you have multiplied the period, right? Multiple of the period. If we satisfy this condition, the period for tangent is pi, right? You have put n multiply pi here, and n equal to 0 plus positive 1, can you see?
Mm-hmm.
And plus minus 2 and so on. Yes. Actually, if you are familiar with this notation, so this is method 1, can you see? So
Mm-hmm.
this is a method 1. If you are familiar with this special ratio, then we can use another method 2, can you see, directly. We just rewrite that as method 2. Can we just rewrite this z equal to, can we factorize 2 first, right?
Yeah.
It must be very special. Can you see that's negative 1, and there's I, see, negative 3. So how can we make up the sine and cosine? Do you know what I mean?
Mm-hmm.
So in the space, of course, we know answer is a 60 degree, right? It is this angle is is a 60 degrees. So we have divided by 4. Ah, that's
Mm-hmm.
right. So that's another way. So we know this is angle we're looking for, and we know that we have to divide it. We have square them. Can you see? We have square them divided by 2. All right. Or do we have to? Oh yes, that's a special angle. So so in this side is 2, this side is 1, this is √3. Do you agree?
Mm-hmm.
So what is cosine? So this should be our cosine. So basically cosine theta must equal to -½ right?
Yeah.
And the sine theta must equal to -√3/2. So what is sine theta in this case? Yes, it's sine theta. Can you see?
Mm-hmm.
Can you see the method 2? Is it give a similar result? Give a similar result. Of course, you have to also added the period, okay? Because there's any theta which is a multiple of 2 will give you the same result. I'll do it again. So any theta which is just this theta added a 2 pi, can you see?
Mm-hmm.
So any theta from here give you the same answer. Let's do it again. Added the 2 pi will give you the same answer. Okay.
Mm-hmm.
That's it. That's question 1, isn't it? So that is there are 2 ways to solve these puzzles.
And then it says the second part of the question is
Yes. Show something. Show that the roots, the roots of the equation, right? Are -2. Okay. So you use the result obtained, right? To work as a rule. Oh, that's interesting. Can you rewrite that? Is that z square? Does that involve z square? The first term is z square or not?
Yeah.
Is z square? How about it? This is 4z? Is 4z plus 4z? Ah, that's quadratic unity, right? Plus 16 equal to 0. How do we solve that one? Oh, so this is the equation of this one. Oh, I see. So the quadratic question will give you two conjugate, right? Conjugate solution. Okay. Oh, you just use the quadratic formula, isn't it? Can we apply quadratic formula? We got coefficient here. This A is 1, B is 4, C is 16, right?
Yeah.
Can you work out this formula to double check if that is If we use a quadratic formula, can we obtain the same result? That's what means show, to prove or demonstrate. Can you see?
Mm-hmm.
Do you want to do by using quadratic formula? Yes, that's quadratic formula. In this case, the discriminant is negative. That's why you got the imaginary number. A is 1, can you see? So that's divided by 2. Oh, good.
Mm-hmm.
Okay. Got 4. Yes. 16. You can factorize 16. Can you see? If you factor 16, that would be 4 multiply. The inside is a 1 minus 4. Can you see? It's much easier. You don't have to do square. Can you see?
Mm-hmm.
You just factor this as can we factorize 16 here? That's what I did here. Can you see?
Yeah.
Factor this one, that would be much simpler. So that is this is root 3 multiply. Can you simplify this? What is how to rewrite negative square root negative 3? How can we rewrite this number? Using the I equal to root negative 1. Yes, that's right. In this case, it's positive. Can you see?
Mm-hmm.
So that will equal to 4 multiply 3 and I. Can you see? It will be 12. Is that could be 12?
It'll be -3.
Sorry, root 3. Root 3, sorry. Root
Mm-hmm.
3. Yeah, root 3. So basically, I just give you some detail. If you have, say, -3, so you can rewrite it as positive -3, multiply -1 square root. Oh, yes, identical, isn't it?
Mm-hmm.
Good. This is a typical question. So this is part 1, right?
Mm-hmm.
This part 1. It's part 2. Okay, we have done both. Okay, let's go to next question. Can we go to next page?
Yeah.
So 2. It's quadratic, right?
Mm-hmm.
Quadratic terms.
This is a continuation of the question from before.
Oh, okay. So it's part 3.
Mm-hmm.
In term of that one, so express the rows in term of this result, right?
Mm-hmm.
So what does it mean? Express the rows. We got 2 rows in term of one of them, right?
Mm-hmm.
What we can do? We can factorize that, can we? I don't know. I'm not quite follow this. What is the required question? If that quadratic solution have the root, yes, you can factorize that, yes.
And previously the things were -2.
Yes, conjugate. They have 2 rows, yes.
So for this one, it can be -2.
Mm-hmm.
Oh,
What
no.
is it trying to what's their question? I'm not quite sure. Express the rows. So they obviously have 2 rows, right?
Mm-hmm.
In term of one of the rows, in term one of them.
Mm-hmm.
in terms of one of them. So one is conjugate, isn't it? Right?
Yeah.
Yes, that's your answer. Is this your answer, right?
No, we need to express these as this somehow.
No, it's quite not clear what is trying to ask, because we know the quadratic in principle can give the two rows. We know both, all right?
Yeah.
Now, if you want to write one of all rows in terms of this one, we just say, can we call this Z1? Can you see this Z? Can you call, that makes sense. This is Z1. Conjugate, you can use this. So this you can use Z. Can this Z1? So this Z1 equal to the I know what he's trying to ask. We just a concept. Can you see? Okay. Another is conjugate. Can you put this note here? This is called a conjugate. Do you know this notation? You can use this one. So if you use this, so this one row, another row, Z2 is a conjugate. Can you use this notation here? That will give you 2 plus 2 root 3i. Can you follow me?
Yeah.
I think that's what I'm looking for. Okay. This just use notation. Can you check your notation? Use this star here represents the conjugate.
I think we do the conjugate like this.
Oh, okay. All right. Different textbook. All right. Okay. Okay. Use your notation then. Okay. But that looks at mean value, right? That looks at mean value. And some textbook use this value, dagger, because some even use dagger. Anyway, that represent the conjugate. Okay, fine. All right, that's it. Next question. Integration. N is the integer, right? So we're trying to integrate this. Question 3. Find the value of I1. Okay, so that is a general formula. Can you see the general of I1? Yes. So I1 is simple, right? I1 is just net x equal to net 1 equal to n equal to 1, isn't it? Okay. All right. Can you do this one? We are going to do this definite integral when n equal to 1. Okay.
Yeah.
So that means n equal to 1. Okay, how can we solve this integral? Yes, we can do that integral. So which row which method can we apply to solve this integral? Which one? Have you studied integration by substitution? Substitution, have you studied?
Yeah.
Okay, so can we introduce a new variable to y just equal to x? Or you couldn't simplify. Can we simplify?
Oh, by substitution, right?
Yeah, by substitution. Think about it. How can we choose a u? How can we introduce u in order to simplify this integral? Good idea. So use the u to represent everything inside the square root, right? That is the origin of trouble. So we can get rid of this trouble by introduce the u. Yes. Very good. Very good. Yes. What can we do next? Yes. Yes. Half plus 1. Yes. Very good. One term is 0, right? Oh, no, oh, you got 2 terms. Okay, you substitute it by x. Okay, that's fine. Good.
Would that just be 1?
I think so. Yeah. The base is 1. No matter what index is, it's 1. Yeah. Very good. Okay. Do you have B? Part question B. Oh, your math is so good. You can work in any profession by introduce a formulation for each of them. Yes. Using integration by parts. All right. To save another one. To solve integration by part. Yes, I can see how can we solve integration by part. Wow, in larger than 2. So this is general formula, right? The general formula. Wow, that's fun. Yes. So to use integration by parts, you have to decide which one should be differentiated. X or square root. Okay, which one can we use? So integration by part is rewrite this integral. Can you see? Can you write integral here? Can we can we use n now? Because that n is larger than 2, right? So we just use n to write this general form here. 0, 1, that is x to the power of n. Okay, and take x squared dx, all right? Well, we have decided how to move forward by writing a product. So basically, we have to rewrite this integral first as u dv, all right? So which is u, which is v? We have decided. So which is u, which is v? Have decided this one. U equal to x. Yes, you.
Oh.
And U represent the U to power n, right? Isn't it?
Yeah.
Yeah, you're almost correct. Oh, okay, you can do it again, but almost correct. And okay, go on. So what is according to integration by part? You know that that's equal to product of these two minus just swap these two du. Okay,
Yeah.
and of course you have put this 0, 1, 0, 1 here.
Oh, I just realized that this should be no.
That's right. You got first derivative. Wow. Not straightforward, right? This time.
Yeah.
So I just check. Why did you work out the both derivative first in the first step? Why do you have to work out both derivative first? Which is u? So in this case, can I follow your definition? So your u is this one. Is this u? And that is a v, right? So another one is v. This is v, right?
Yeah.
So, if that is the case, if you follow you use a dv as the first derivative. Can you see? Basically, I can follow your writing. So in this case, dv, can we work out the dv? Can we work from here? Basically, dv is equal to dv dx. So this is dv equal to dx. So basically equal to 2x divided by root 1 take x squared dx. Can you see that? And if that's what you're trying to do, I don't think so. So this is u, right? But did you use u and v? You have two to start with. You have two choice. Did you use v du or not? Did you use v du or u dv? I would like to ask you. You introduce this as first derivative of u, and you integrate that, right?
Yeah.
You get u, and I'm not quite sure. I don't understand. Why did you do this? Why did you do this?
That's how we've always done integration by parts because it's UV.
Let's just go to next page. It's a bit crowded. Let's go to next page. Can we copy that? So we are dealing with this integral. I know that integral. We write down. So this is u. So this is x to the power of n. Okay, can we just use indefinite first? Okay, forget about definite notation. We just work on this first. We got mathematical form first. So this is dx, right?
Mm-hmm.
So you suppose this is u equal to can you go back to what's your idea? So u dash equal to you just this the first part you represented by first derivative, right?
Mm-hmm.
And so in this case, well, if you put them together, so what is I think that is not the way I usually do. If you so what is objective to introduce u dash and then find the u as x n plus 1 divided by that copy.
This is how we've always done integration by parts.
Yes. That's okay. You see why? That's why. So basically, yeah. If I rewrite this part, that's my notation. Okay. My notation is just slightly different from yours. That is a dv. Can you see?
Yeah.
Therefore, the first term is right, but the second term is VDU, you see?
Mm-hmm.
Can you see my relation is the same because in this case,
oh yeah,
du is equal,
yeah,
u dash dx, right?
Mm-hmm.
Okay, so, but the question is, how do we choose the u and v? That is the question, okay? Now, if you use your idea and the u, so you have to decide what is v and what is u, okay? What is v, what is u? If you decide this u, I think it's irrelevant. Why did you choose this u?
Just because I just thought that it might.
But simplify that, right?
Mm-hmm.
Well, I think because if I give you a trial, right? When I see this one, because every time you have to differentiate, if I just do something slightly different, can we just let u equal to this x to power n? Can you see? This is my trial, right? This is my trial. So and the v, what is v? Then we have put yes. So that if I rewrite this part, first of all, let's rewrite this part as x to power n. That equal to after that one, that will be the equal to, because I know the result. So the result will be like, you work out the result already, right? I trying to reconstruct this as, well, we'll just call this, if I use your notation, I call this, simply call this u, all right? And this is v dash dx, all right? I only integrate one of them, all right? So given v dash equal to root negative x squared, how about the v? What would be the v? That is the question. Because when use integration by part, we have decided which is u, which is v. Can you see?
Yeah.
Now, obviously, in this way, this is our dv. Can you see? This is our dv. Okay. Are you sure? First derivative over, this must be 3, can you see?
Oh,
do you
yeah.
agree? Do you agree?
Yeah.
In addition, but not as simple as that. We have this 2x here. How can we solve this puzzle? This square, sorry, this square.
Do we have to?
Well, you have to check, right? Because if you do, if you integrate this, if you integrate that, so we have to check. So what is the d from here? What is the dv dx? Okay. So we double check if this work, okay? If we double check that, it doesn't work because this is if you take 1 and this coefficient canceled, right? Coefficient canceled, and that is half. That part is correct, but you have multiplied 2x. Can you see?
Yeah.
So this is not right. So as a result, this choice is not right, given this.
Oh, if this is the derivative, then isn't this the integration of v?
Integration. Yeah, we're trying. We're trying to work out the derivative. Can you see?
Oh, okay, yeah. So then it would be negative.
We just check if we can. We just check if this formula is the same as our original derivative form. Negative. How come? If the function, say if the function equal to this form is not 3, right? I follow yours. If function is not 3 but half, right?
Because this is the derivative of this.
If you found, so yeah, if you assume this is your v, that I just follow your idea. So if this is your v, right? If we just assume this v, then after we done the first derivative, we should get something. We should get identical. So this part must equal to this part. Can you see? But it's not. It's not equal to. Are these two blue color the same or not?
When you do it, shouldn't you times the half by it?
Yeah, this is negative half, yes.
So it should be not negative, but it should be half times this.
I don't think that is the right way to go.
Because when you go 3x squared is 6x.
That's first derivative, right?
Yeah.
So when we derive, yeah.
So when we derive this, you'd also times it by the half.
No. My question is whether this formula is true. Okay, we are talking about that. Given, so this is the question. Given that the first derivative equal to root, can you see? 1 take x squared. What would be the v? Can you see? Okay. So there's no clear answer. You agree?
Yeah.
If we assume if v equal to your formula, okay, if we assume your formula is correct, right? If you assume your formula is correct, then the first derivative must give you the same formula over here. Can you see? But your answer is not right. Can you see? That would be half. Can you see? If you follow yours, that would be x squared here. X squared, that is negative half. Can you see? Multiply negative 2x. Obviously, this derivative formula is different from yours. Can you see?
Yeah.
So maybe this is not the right way to go. Can we just go to another alternative? Can you see? I give you another trial. So the trial 2. Trial this time, I will just use the u equal to root. Can you see? It's just equal to u equal to this square root stuff, all right? And then what I do, I put this inside the differentiation. So in this way, the integral I show you will become that this is u, and that is d x n plus 1 divided by n plus 1. Can you follow me? So nothing changed. Can you see? In our case, we just introduce this u here. Can you see that? And then I know this is our v, isn't it? If I write down here, that's our u dv. So we know which is v now. V is equal to this function, n plus 1 and n plus 1 divided by n plus 1. Can you see that?
Yeah.
Then we can use the formula for integration by part. Can you see? So that will equal to v du. Can you see? Now, what is du? Can you work out from here? Can we find du dx? We just found the first derivative. Du dx, that is half. Can you see? And 1 take x squared. That would be negative half, right?
Yeah.
Negative half and multiply negative 2x. You see? Now, how can we simplify this one? So the first term is uv, okay? And the second term is v. V, what is v? V is x, can you see? This is x plus 1. That's n plus 1. That's u. That is a v, can you see?
Yeah.
And n plus 1. And then we just multiply our result here. So this is half. Can you see? Half is 2 canceled. Can you see? Wow, this is very detailed, many detail here. These 2 canceled, right? So that will give you, in this case, we can see, we can multiply this one that as x square root and 1 take x squared dx, all right? Wow, things getting complicated now, okay?
Yeah.
And x plus this became x plus 2, can you see? So it's not easy. uv minus, we just put them together. So that is x n plus 2, all right? Divided by root 1 plus x squared dx. So this is still not easy to integrate. Can you see?
What happened to the n plus 1?
Ah, n plus 1 should be still there. Yes, I forgot. It's n plus 1. But this is just another trial. It may or may not work, all right? Because if you go this way, we got this form. I think this question you need to, you found the loop, all right? This is you need to find the loop in order to solve this one. But then again, can we just do substitution first? Because the reason we cannot move forward because this is a square root there. Can you see? Can we use a substitution first? Because we can work out the general formula for this form. So this formula, original formula is that's x to the power of n and root x squared. Can you see? And dx. Yeah. Can we just use u? Can we just use or any? We don't want to confuse with u. Can we use w? Can you see? W equal to 1 x squared. Okay. So in this way, so can we just divide that, find dw dx, right? Or equal to negative x. Do you agree?
Yeah.
So therefore, we can, from this equation, we can find the dx is equal to 1 over x negative, right? dw, all right? So in this way, we just do the integration by substitution first. So that will become x negative 1, can you see? X n minus 1, can you see? N minus 1, w, can you follow me?
Yeah.
Root square root and dw. Can you see that? So what I suggest we just use these two. We started from here after the substitution. Do you agree?
Yeah.
So we don't have worry about the square root. So because this one, this is easy now. If we just call this is can we let's call this this is u. Can you see? Can we call this n plus 1 is u? And V dash is equal to, so V dash equals to W to the half. Now, based on this, can you work out V quickly? Given that V dash is equal to W root. So that will be W, yeah, that's right, divided the constant, yes, okay. Well done, well done. So this is probably the one we can put it, rewrite this as 3, can you see? 3, 2. Okay, so then we can rewrite this as negative, doesn't matter, this negative sign here, equal to U dV, right?
Yeah.
In this case, U is, so U is x to the power n plus minus 1 or minus 1? Well, minus 1, right? Sorry, minus 1, n minus 1. And that will equal to, V is equal to this number, 2 half, 2 over 3, W, 5 over 2. Can you see? So it's 3 over 2. Now, this is, my writing is wrong. This is 3 over 2, right?
Yeah.
Yeah, you are right. 3 over 2. Okay, we got it. So then we just integration by part, all right? Let the UV take integration VU, okay, V du, okay? So what is du from here?
Du is xn minus 2.
Well, n minus 2 is far away, you see. So probably this is not the right way to go, because in this case, we will end up with, oh, this is dw, dx. Probably this is not the one, dw. Because we have no chance to simplify this integral. Can we just go on? Doesn't matter. This is a uv, right? Sorry, uw, uv. Take du. So this is du. This is du here, right? So write everything here. V is 2 over 3 w. 2 divided 3 divided by 2. Multiply this integral. Wow, that is not easy. Did you say that is equal to, did you say equal to? How did you? This is the first derivative. Is this the first derivative?
Yes.
Well, we have followed this one. Can you see? The first derivative of du dx is equal to, yeah, n minus 1. You are right. N minus 1 multiply x. Yes, that's right. N minus 2. Yes, all right. So that is our d. That is worth n minus 1, n minus 2 multiply n minus 1 dx, right? But unfortunately, this equation doesn't give us let's give another trial. I think we should, can we just, this is another trial, can you see? I think we should put this inside now, can you see? This is another trial, the trial 3. This time, I just put this I equal to negative, can you see? W, I don't touch this one. Okay, I don't touch this one. Oh, but this must be dw. We have to touch this one. No, I don't think we are not on the right track. All right. And what we can do, we probably have to think something else. Things doesn't work. The 3 trial doesn't work. How do we find the general formula for this one? That is the question. So alternatively, we should find if you put this x inside this one, that becomes n plus 1, right?
Mhm.
So 1 minus x squared, that can be rewritten as x n plus 1 divided by n plus 1. All right.
Mhm.
If I do this direction, we do the first derivative of this one. Getting complicated. So this, can we try this one? So this time, can we try another one? This is u, this is v, all right?
Yeah.
So therefore, we got a negative, doesn't matter, u dv. So that u dv can be written as, I put a negative sign here, uv minus v du, you see?
Mhm.
V du. So what is v du? Wow, we know the du, can you see?
Yeah.
du is equal to half and 1 take x squared half, negative half, and multiply negative 2x, right?
Mhm.
We tried this before, did we try this before? This was these two
Yeah, we
cancel.
did
We
try.
did try before.
Mhm.
If that's the way to go, so we have to, so this, can we just keep going for a while? So that is a negative, with the negative sign here. Here v minus v, what is v? V is, we put n minus 1 here. It's n minus 1. So we put n minus 1 in front and divide n minus 1. So that integral will become, that is v du, right? V du, that is v, that's x n plus 1. Multiply this one, du. Du is x divided by root 1 minus x squared dx, all right? So in this way, yeah, that's probably the right way to go. Can you see? So in this way, if we combine these two formula, can you have, we got 2x here, right? So this integral can be written as, so because the product, we can keep the product part. So that can be written as n plus 1. That would be the x n plus 2, right? And then this factor is this one. Oh, can we just rewrite? Oh, we can't. We have derived that. We got dx. I just write down the result first to see if, how far we can go. Maybe we didn't choose the right the beginning. At the beginning, the direction is not right. Okay, can we check this one? If any chance we can solve these puzzles. We got n to power n.
I don't think so.
I don't think so. I think we have to check, first of all, the, yes, I don't think this is the right track. All right, let's just look back. So this is integration, this is the original question, right? To the power n squared, yes. Whenever you see this 1 plus x, there's another assumption is just to use the x equal to sine square. X squared equal to sine. X squared equal to sine. Sine square equal to cosine square. Okay, maybe that is not right. That is another way to go. Okay. Well, have fun. It's just have another alternative. Whenever, so there's some strategy you have to use correctly. If you don't, then you got, we will end up in the no through road. Can you see? We are in the no end through road. So this one, can we do some transformation? Can you see? If I just this is x to power n, this is 1 to minus x squared. Can you see?
Yeah.
This just, can we just invoke the trigonometry? Can you see? How about x? Can we just write x as sine theta? Can we? You see that? If I do that, and we still got we still have trouble because that the dx is getting complicated, right?
Mhm.
How about dx? Dx d theta is cosine theta, right?
Yeah.
That's a cosine. That's terribly complicated. Oh, good. Okay. So that implies that dx it can be written as oh yes, oh hang on, d theta, hang on, yes, that will equal to cosine theta d theta. You can follow me?
Mhm.
So therefore, the original formula can be written as that is sine, can you see, to the power of n theta. Can you see? That's 1 plus n is cosine. Can you see? Square root the cosine.
Mhm.
Oh, we have hope now. So that's dx is cosine theta dx. Oh, that's the right way to go. Okay. So we have this sine to power n, right? And this sine square, you can see. Cosine multiplied cosine is cosine square. Cosine square is 1 minus sine square theta. Can you follow me? And this one, by substitute, we can write that the two integral sine to the power of theta, d theta, right? Minus another integral is sine n plus 2 d theta, all right?
Yeah.
So that is right way to go, all right? Can we see the hope now? We should be able to solve these two separately, all right? Can you follow me? So we end up with dealing two integral. One is I1 and another is I2, right? You understand? So the question is, how can we solve this integral? Any questions so far? I1 is equal to sine, can you see?
What does d0 equal? D theta? Oh, wait, no, I see.
Can you see my point?
Mm-hmm.
So basically, we have to work out this first, all right? That is the right way to go, all right? We convert that question into the trigonometry integration, all right?
But then how would we get the n minus 1 over n plus 2?
Oh, I'll talk about next time. This is the right way to go. If you can follow me so far, then you can try. In this case, we invoke, from here, we invoke integration by part, all right? We integration by part here. And also, it's dependent on n is the integer, that the result, whether n is, whether n is, can we say, whether n is even or odd, okay? So in principle, we should be able to solve this problem, right? We should be able to solve this problem. I show you next time, all right? If you want to solve this two, you have to work out these two integral one by one. But this is certainly, this is the right way to go compared with trial we used, all right? Okay, we'll probably stop here now, all right?
Okay.
We will continue on Friday to see if you can continue, all right? Because you were if you can solve this integral, then we can solve this general formula.
Yeah.
Okay, we'll save that. And stop.
Okay.
Okay, see you Friday.
Friday.
Right, goodbye.
Thank you.
Yeah, right.